Hi, I'm Nick. This is an app I've been working on to consume the COVID-19 data put out by Johns Hopkins University. I've got a sort of introduction, but chances are if you're seeing this, you already know me, so I've put it at the end. A few weeks ago, the Financial Times put out a visualization. Actually, I was supposed to start with this in this mode with a log axis scale. Financial Times put out a visualization, and you've probably seen one by now, but this is what they're still updating. It's still on the web, and it's great. I recommend it. I wanted to have one that I could actually interact with and explore with fresh data in it every day, and that's what I've been working on. Theirs is a lot prettier, but this one is interactive, so they're interesting in different ways. The other somewhat interesting thing about this one is you can chart individual US states and provinces of a few other countries against whole other countries. So here we can chart New York versus Italy. Note that there's no US country on here. We're just charting US states versus a whole other countries. Note the y-axis is in a logarithmic scale here, so it doesn't step up with normal linear scale. And you can switch between, and the charts look totally different. And maybe you've seen a bunch of these already. Maybe you're going to see a lot more. So let's go over it a bit. Oversimplifying all the fancy fun mathematical modeling of these curves. There are phases, let's call them. There's the first phase where the growth is really unrestrained and it closely follows and approximates an exponential curve. At some point, it does presumably stop being an exponential curve and turns into more of a straight line going up and still terrifying everybody, and then it levels off at some point and falls off, and you end up with exponential decay over here, slower than it started, but okay. So at the beginning, they closely track exponential curves. After a while, they start to more closely track linear curves. So log axis scales are a primary tool to sort of visualize this sort of thing. Let's come back to exponential curves, though. If the time is on the x-axis, then and you're talking about an exponential trend, then there is, roughly speaking, a doubling time. If the doubling time is 2 days, then every 2 days the number is twice what it was. So it's not hard to look at one of these curves and see that it's getting steeper as it goes. It's really hard to look at lots of them and make much sense of it. You can make sense of maybe 6 lines on here, but look, there's quite a lot in the legend, and they're just buried and flattened against the bottom here. We can't see them at all. So let's try it. Let's actually reset and look at the US, all states in the US. And I'm going to draw your attention to something else that the Financial Times did. That's the first person that I'd ever seen do it, where they normalized the x-axis to be the number of days since some event occurred. And this, you can change it. It defaults to being the number of days since the 100th confirmed case was hit. In this case, it's by each state and how many days have gone by since that day. So each of these points on the far right is yesterday, but they're all at different points on this x-axis. And there's some normalization that I could still do to clean this up, but it's the list of things to do is endless. So if we look at this on a normal linear axis, this is, New York and New Jersey are in, that's what all the news is, as it should be. It's really bad. Let's look at the other ones that are flattened down against the bottom that we're not really able to see right now on this chart. So we take away New York and New Jersey. Well, we got a lot of other ones. They look like they're getting steeper as they go. So let's take away Michigan and California and Washington and see what we're left with then. And you see, oh, okay, it looks the same. This is a weird fact about exponential curves. If you look at them on different days, they actually always look the same. So we're kind of going back in time. Now their x-axis is down to day 14, but they're all pretty similar looking. It's just the y-axis values are kind of getting lower as we rewind back in time. What we're really doing is looking and seeing what the states are that should these trends continue. We're looking at the states that will be in the news soon. Illinois, Louisiana, Florida are in the news already. Illinois, I haven't read a story about Illinois. But This is so sort of words kind of fail me, but it turns out it's really hard to deal with these exponential curves because there's even the ones at the bottom, even the ones down here that look flat, they're still exponential. We just can't see them because they're flattened against the bottom, and that's what the normalized, that's what the logarithmic y-axis is for. On a log scale y-axis, an exponential curve always makes a straight line going up. And if that line starts to not be a straight line, that means that trend is not following an exponential track anymore. It may be following a linear track. This gets off into the weeds on some tedious high school math, but I'm not going to go into it too much. So this line makes it a little easier to see where everybody is. Even if some of the numbers are actually still quite small, we can still chart that the doubling time is pretty significant. I know everyone is, the chief thing that people say when they see this is that this is charting confirmed cases and charting remaining sick patients and testing positive patients, and not charting actual carriers out who necessarily aren't at the hospital. They might know they're sick, but they might be at home. I understand that. That is absolutely true. But this, for better or for worse, is at least a metric of what the healthcare system in these states is currently dealing with. It's their known unknowns, I guess. So if it itself is growing exponentially, that in and of itself is of great concern. Yes, whether or not there is a far, far larger population out there, you can infer that there is, in fact, a far larger population of carriers because the number of quite sick people is growing exponentially. So some of them lapse into behavior where they're not growing exponentially anymore, and they start to come out of it, and that is interesting. And there's some weird stuff down here I've been playing with. I'm sure other platforms would play with this more efficiently. So I'm going to go back to the linear axis for actually no, I'm not. I'm going to reset back to look at the sort of smattering of different countries and key US states right now, but on a log axis. So there's Italy marching along. If you look at flip back to the linear axis for a second, Italy is still, well, whatever shapes these are going to trace out, they're going to look pretty similar to this curve, but we can already tell that they're going to be quite a lot larger than the China curve. And the other takeaway from this is that some states are just a few days behind or a week behind. You can measure that with visualizations like this. I think and I hope that we'll see more of ones like this, but breaking apart US states. Louisiana was concerning me a week or days ago, and here it is, getting to be some quite big numbers. Charting out this course, you can see where it's going to be, and that's of great concern. Anyway, the preamble that I said I saved for the end. I am at least a Splunk expert. It's really weird to use Splunk for this. Splunk is a big data product, and this data set is, in Splunk terms, very small. It's of great importance, but in terms of actual data and points to graph and things to index and search for, it is inconceivably tiny in Splunk terms. So I'm fairly sure there are other platforms out there better suited, but I'm no good at building things in those ones, and I'm an expert at this one. I've been a full-time Splunk app developer for as long as there's been such a thing, because I used to work there, and I'm one of the original engineers that built that product, this product. I give talks at the annual Splunk conference on various advanced things. So at least I'm not some crazy person who decided that this was the year they'd start playing with data visualization. I've been doing this for kind of a long time. This, by the way, is not technically a Splunk UI. This is a proprietary other UI. And thanks for watching. If you want to play with this yourself, step 1 is the difficult step. That is downloading a 60-day trial of Splunk Enterprise from Splunk.com and finding a machine to install it on. It's probably the second part that's the hard part. It will actually install onto a relatively decent Windows laptop, but I wouldn't say either one of them is going to be particularly happy about the other one. It can be done. If you do go that way, I strongly recommend going into Windows Services and making the Splunk D service not start automatically when Windows starts, because you'll forget you did all this next week and wonder what the hell is going on with your laptop. And if you know any Splunkers or you have a Splunk instance at work, put this app on it. It's about 5 minutes. You just click buttons, install three apps. It ships the data inside it. Did I mention this data set is tiny in Splunk terms? And this app updates every day. And you can click around this and point and grunt and ask me questions and complain about this on the Slack channel and do whatever you got to do. Thank you for watching and stay safe.